Ok.
Vous pouvez commencer.
Je peux commencer. En français donc. So I did a talk today, and I forgot there was capital for English and French. There was an error in Debugfs, and I didn't know there was a capital in English. When you put English speaker and French speaker, you need a capital. I learned it today. Okay, so I will try to talk about Ftrace. And basically, I am a French Linux developer, writer, and teacher. I am a CTO for a French company working partly on embedded systems. It's quite a big company in open source, but we have about 70 people working on embedded systems. It's called Smile ECS. Smile is the main company, ECS is a department. And I wrote a book, several books about embedded Linux, and the last one, Linux Embarqué in French, is embedded Linux, and the last one was available in the end of the last year for Christmas. If you 8 people, you can offer my book. So what is Ftrace? Is the official tracer for the Linux kernel. There are several tracers in the Linux kernel. The first one of the first one was LTT, but LTT was not mainline. I don't think it's mainline today. So Ftrace is available since 2.6.31, and it's mostly developed by Steven Rosted from Red Hat, and Steven left Red Hat some months ago. He's working for VMware today, and he's a developer for Preempt30, which is quite close to Ftrace because you need to measure some problems with Preempt30. So there are lots of features for tracing. You can trace, of course, you can trace functions, you can trace events and latency. It's not a debugger, but it's a kind of profiler. So I say the debug application with Ftrace, but it's not really a debugger. It's available in most of standard distribution. For example, on my Ubuntu, you can use Ftrace. I will show you. And it's based on Debugfs. If you want to activate, if you compile your kernel by yourself and activate Ftrace, or deactivate if you want to, you have to access to kernel hacking tracers. So for example, you have to mount, if it's not done, you have to mount the Debugfs on syskernel debug, and on syskernel debug you have an entry tracing, and you have to access as root, and you can see all the files, the virtual files to access the Ftrace system. So there are some important files I put in bold as trace, which is the result of Ftrace, available events and available tracers. Very important file is a tracing on, which is a switch for activating or deactivating Ftrace, and this is on my Ubuntu. It is default to 1, so you should put knob to the current tracer. Otherwise, you will trace everything, and you will get a Commodore CE XT64 inside of a PC. It's a code for Steven Rosted. I'm not the author. So the procedure is quite simple. You set a tracer and a filter. For example, wakeup RT. You enable tracing. You run a program. For example, Hackbench, which is a program to generate load on the system. You disable the tracing, and you can get the result. For example, tracing makes latency. I will say, but there is a solution if you use an embedded system to run the tracer on the system, and to send the data to a remote PC, for example. Because of course it generates big files, and so for example, if I use Yocto or Buildroot on a Raspberry Pi, the file system is quite small, and so the files can be on the file system, except on the boot partition, because it's bigger on the FAT partition. I don't know why, but it's bigger. So it's better to send the file to the PC. There is another example. For example, you want to trace the function of a simple driver. You set a function graph for function. Function graph is much better because it sets a graph of a C-like graph. You set the filter. You trace only the function of my driver 3. You trace. And you know Toto for French is like a fou and bar for US, and so story of Toto are very famous in France. So you send something to the driver, and you can get the result from the trace. So if we have time, I can show you to have both strace and trace to the two way of debugging the system. So one slide only on the basic internals. It's based on it's a bit surprising, but it's based on M count. It's a GCC profiler, just like in user space, but not really the same. When you compile with -pg, you generate a call to M count at the beginning of the function, but it's there is lots of overhead. There is a complex system embedded in the Linux kernel to replace the mcount to NOP instruction. There is a program to record the counts, etc., to make it work very nice. But it's based on mcount, and mcount is very old. It was available on Unix before Linux. I remember it was on Unix already. So there is a reference conference from Stephen about the subject. So real-time programming mostly is based on periodic tasks. You can use, for example, POSIX timer for soft real-time, such as timer create, timer set time, which will generate a signal. And the signal is not real-time, really real-time, not hard real-time, but it's a soft real-time. If you want to use hard real-time and better results, you can use a clock nanosleep instead. For example, we will see a test with Preamp 30 at the end on the Raspberry Pi. You can get GPIO and with a picoscope, actually a small oscilloscope, you can measure the system load and see the latencies. So this is on a BeagleBone Black with a 1 millisecond period. It's idle system, quite idle system. 1 millisecond is not so short, but if you start some task, you will get this result, which is not very nice. It's with the Hackbench tools from the RT test package. So if you want to test events in real time with Ftrace, there is one way to use a sched wakeup event. So you set NOP to the current tracer. It's not the same tracing way of tracing. And so you put the sched wakeup to set event. You activate the trace. You start an example cyclic test, which is an example of the RT test package. We generate some threads with priority, etc. It's just like this. I can show you some demo. Okay, cyclic test. Okay. So it's on the PC. So you will see the worst case on the right in microseconds. It's just a periodic task with a 1 millisecond period. Okay, so it's quite simple to use. If you got tired of slashes because it's a bit boring to do echo, etc. and cut, you have a trace-cmd command, which is in text mode, written. It's a contribution to the project, and there is a kernel shark, which is based on GTK. It should be based on Qt in the future because Steven will work on at VMware. He will work on upgrading the kernel Shark at full time. He said. So well, it's a good idea because kernel Shark is not that stable, and I don't like GUI a lot. So for trace-cmd, you use a record and report, record to record and report to display. Well, and you create by default. You will create a trace.dat file. You can create use a remote server access in listen on a PC. For example, you trace-cmd listen with a number of ports, and on the target, on the embedded system, you say to send the data to the PC with the same program. So trace-cmd record, -e sched wakeup, and you will see if you report on the PC, it's much better to do that on the PC, and the file is on the PC. You play the file, and you can check there is a 1 millisecond difference between each event. Well, it's only text mode, so you have to do better things for marketing people, for example. Okay. Or communication people, or anything you want, or your mother-in-law, or anything. So for the text mode, you have to extract data. You can use GNU-plot, and you have static results. But GNU-plot is very powerful. Kernel Shark is dynamic and interactive, but it's a GUI, and it's not that stable. As I say, it should be improved by Steven. And there are lots of buttons in kernel Shark, and I hate buttons, so it's quite strange. Sometimes it works. It works, but I don't. Well, it works, but I don't understand really the results between two tries. So it's a bit strange. Well, something like that. So it's very complicated, with lot of scholars. So we select the right CPU, and you can drag with this fucking mouse. Of course, it's for a demo, so it doesn't work. I will. Okay, it's best. Okay. Check. You will see. Well. So here you can see you can get the value. So there is a. Okay. Well, I don't like it, but it's fine for display. Should be better in the future. Okay, so I did it in the Thalys today. Just add two slides about kernel Shark, so you can see the timestamp here, and the next one with the next event, you will see the timestamp is updated about 1 millisecond. Okay, it's nice because it's interactive, but I will show that another way to work with Ftrace. I will test Preempt30 on a Raspberry Pi. With a 1 millisecond period, another one, but it's a program to generate activity on the GPIO. So there are two versions. The first one used on POSIX timer and signals, SIG alarm signal, and the second one is based on nanosleep. So you can load the Raspberry Pi with the float ping or anything you want. And there is several ways to test it. The first one records the events with a real-time program, but instead the other, so with no static priority. Okay. The second one uses sketcfo with a high priority. So you can set the priority of a program on Linux by using chrt. It's much better than writing the code inside the program. I did realize this 2 years ago. So you say get FIFO F and 99 for priority, and the last one you do the same test with a real-time program, okay, and you compare the result with a GNU plot. So the get FIFO with the timer is awful. You have a line here, but with a kind of cloud around. It's not a cloud. Okay. This is not a point. This is a legend. Okay, because every time I show the picture, everybody say why is the point is here? It's a legend. Okay. The second test, it's sched other, but with clock nanosleep. It's not real time, but it's not that bad. Okay. Because there is no signal. And the third one is preempt RT with sched FIFO and high priority. So it's a best. Okay. So I can show you maybe. I can show you some 10 minutes left. Okay. For example, how to use Ftrace directly. So, sys kernel debug. So on sys kernel debug, you have lots of tracing subsystem. For example, you can trace. There should be a USB. You can trace a USB transfer, etc. It's not only for Ftrace, of course. So tracing on. Get current tracer. Okay, function graph. Current tracer. I don't remember. Grep. It's better with grep. Okay, I will insert. It's always the same examples. Okay, so it's a very simple driver which reads the data, put it in a buffer, and we send data. sudo my directory. Okay. So I will set the filter. Okay. So you have the new functions. So I put my driver 12. Okay. Okay.
So why aren't you using trace command?
Because it's to take the 10 minutes.
Oh.
No, but it's for sure. Actually, trace-cmd is nice for tracing events. It is my opinion. Trace-cmd is fine for tracing events when you want to record data. But I think /this is better to trace the driver just to show the function call, etc. This is my opinion. This is not the same way to use Ftrace. So if you write Toto again, it works only with Toto in France. Okay, you will see. I forgot to activate the tracer.
Sorry.
No, it's mine. Okay. So I put the function graph tracer, so there is a time of duration. If I change the tracer to function, it will be different. Okay, but it's quite the same. You have the color and it's called by the VFS right, etc. And so now you can display the content of the pseudo file, and okay. Okay, so it's interesting if you have a driver and you want to check the timestamp for the calling. Okay, 5 minutes. So I will tell a story of Toto. No. So if you have any question, do you have any question?
I would like to ask if the Ftrace is able to trace just the function and entry points and exit points, or something else. Can I trace something else in the functions themselves? For example, branches taken or...
Actually, you can put markers in Ftrace. There are lots of possibilities. I focus on real time, but you can put markers inside the code, and you can see the marker. It's called trace marker, Ftrace marker. You can put the marker, and then you will see the marker in. I have some slide about it.
Okay.
If you want just to see, it's in French, but it will be fine too. It's for the students. So.
French encryption.
Yeah. No, it's not this one. Debug. Gtag, FTT, Ftrace. You can do some things such as you can use a trace pinker, for example, in your driver, and and then you will see the message in the tracer. So it's very interesting, and in your function graphs you will see it as a comment. And you can use a trace marker, and for example, in the user space code, you can write to the marker file descriptor before nano, after nano, and then you will see the comment in the function graph. So you can add some things and to help to see what happens in the kernel.
How does this compare with LTTG kernel trace? LTTNG kernel trace.
FDNG? LTTNG. Oh, this is LTTNG. It's a bit complicated actually. When we began to work on the real-time with my company, which was called OpenWide, we started with LTTNG because Ftrace was not available for Airbus, for the planes, for testing the planes. And we switched to Ftrace because LTTNG was very complicated. It's not mainline, so you have to take one version of the kernel with one version of the patch, etc. It's much better to use mainline functionalities because it works on all platforms. It's always the same interface. Well, I think it's much better. But LTTNG was fine, but it was a bit difficult to set up, as you can see on the picture.
To define priority by constant, can it be a variable to be context aware?
The priority?
Yeah.
But if it is real time, the priority is static.
Yeah, but for example, within the stock exchange, when you are close to the fixing, what you focus the most is the execution of the service. You don't want the service to drop because of the consumption of the tracing.
Yeah.
So can you drop the service because of strong contextual context constraint.
You mean regarding Ftrace or?
Yeah.
Well, you can do anything you want. But actually, when you start Ftrace, you start Ftrace with. It's not a problem with Ftrace. It's a problem with the command line. Well, when you start the command with a specific priority. This command. So this is a static priority, but if you want to modify the priority, you should set the setting of the priority inside the program. If you want to change it. But with CHRT, it's for starting a program with a static priority. But you can, of course, you can write a program, but it's not a program with Ftrace. It's a problem with the program itself. Or I don't understand your question.
So you have to reload the service.
No, I don't think so. If there is a modification of the priority of a thread inside the program, Ftrace will trace it without any problem. Yeah.
How Ftrace is compared to extended BPF?
I don't know. I know I extended BPF, but I didn't use it, so I can't answer to the question. Ftrace is you can trace user space program by using trace markers, but mostly is used for tracing kernel functions and events in real-time events. Okay. Thank you.